Hi guys, I'm Julius Antonio Zikandasa from BSME 3C. So I'm going to discuss about types of DC generator. So as you can see in the screen that I've shown to you that types of DC generator has two meaning. Mo ni siyang field excitation and permanent magnet. Then sa field excitation, nasa siya two meaning. Mo ni siya ang separately excite o self-excite. This is self-excite na sa tulo ka meaning. Mo ni siya series generator ug shunt generator then compound generator. So now I'm going to talk about separately excite DC generator. These are the generators whose field magnets are energized by some external DCs such DC source such as battery. Then ang hatag diri is ang I sub A or armature current, then I sub L load current, then si V is equal to thermal voltage, then E sub G is generated EMF, then nasa siya gihatag nga voltage drop is armature is equals I sub A or times R sub A, nga possible nga R over sub is greater than A is the armature resistance. Let I sub A is equal to I sub L is equals I. Then voltage across the load is V is equals I times R sub A. Power generator, sa power generated is P sub G is equals E sub G times I. So mo na siya ang gihatag sa kuan separately excite DC generator. So let's move on to self excite DC generator. These are the generators whose field magnet are energized by the current supplied by themselves. In this type of machine, field coils are internally connected with the armature due to residual magnetism. Some flux is always present in the poles. When the armature is rotated, some EMF is induced. Hence, some induced current is produced. This small current flows through the field coil as well as the load, thereby straightening the pole flux. Then, as the pole flux straightened, it will produce more armature EMF, which cause further increase of current through the field. This increased field current further raises armature EMF, and this cumulative phenomenon continues until excitation reaches to the rate value. Mao na siya. So according to the position of the field coil, DC generator has a three types. Mao ni siya ang giingon kaganihan nako nga na siya tulo ka generator. Mao ni siya ang series generator, shunt generator, and compound generator. Then I'm going to talk about series generator. Series generator is in this type of generator, the field windings are connected in series with armature conductors. So whole current through the field coils as well as the load, as the series field winding carries full load current, is designed with relative few turn of thick wire, and the electrical resistance of the series field winding is therefore very low, nearly point, oh, zero point 0.5 ohms nga siya. So makita ninyo siya ang image series generator. Mura siya sa amateur, muhatag siya sa load, true load siya, patdong siya load, amateur to load. So as you can see, mao ni siya mga kuan, mao ni siya mga given nga gihatag diri. Then let's go on. So shunt generator. In this type of generator the field winding are connected to the parallel with armature conductor. In shunt generator, the voltage is field winding is the same as the voltage across terminal. Here armature current I sub A is dividing to two parts. One of the shunt field current I sub SH and another is load current I sub L. So I sub A is equal to I sub SH plus I sub L. The effective power across the load will be maximum when I sub L will be maximum. So it's required to keep shunt field current as small as possible. For this purpose, the resistance of the shunt field winding generally keep high as to 100 ohms, and large no of turns are used from desired EMF. So mao ni siya ang image nga nakita sa shunt. Mura siya gidivide na murag ang amateur moadto sa load, then moagi na sa Picas tunnel padong gyapon ni load. Mao na siya. Mao sa ning given nga nani kuan shunt generator. So let's go on to compound DC generator. In series wound generator, the output voltage is directly proportional with load current. In such wound generator, output voltage is inversely proportional with load current. A combination of these two types of generator can overcome the disadvantage of both. This combination of winding is called compound wound DC. Mao siya DC generator compound. Mao ni pasabot ani is na combination sa duha ka types of generator na overcome the disadvantage of both. Maong pasabot sa compound DC generator. Then ang compound wound generator have a both series field winding and shunt field winding. Mao na siya nagkaparehas. One winding is placed in series with the armature and the other is placed parallel with the armature. Compound generator has two types, short shunt and long shunt. So I'm going to talk about short shunt. Short shunt DC compound generator, the generator is which only shunt field winding is in parallel with the armature winding as shown in figure. Mao siya, makita ninyo ang arrow is parallel. Mura siya kuan ang curve nga mukuan padong nga to ni load din nasa pikas. Mao na siya Then so on ang given. Then sa long shunt compound DC generator, the generator is which shunt field winding is parallel with both series field armature winding as shown in figure. Kita niyo sa figure, mao gyapon parehas ra gyapon kuan, pero nay kalahian sa ang short is dali ra siya moabot, then ang long is dugay. Then in compound generator, the shunt field is stronger than the series field. With the series field assists the shunt field, generator is said to be commutatively compound generator. On the other hand, if series field oppose the shunt field, the generator is said to be differently compound generator. So, mao na siya. Thank you for listening. Hope na ako masabtan. Sorry kung kuan. Thank you for listening.